presentation, I try to explain our experience in the Brancacci chapel, experience about the integration of several kind of diagnostic system in order to understand the structural health of the wall paintings. The Brancacci chapel has been realized by famous painters Masolino, Masaccio, and Filippino Lippi at the end of the 15th century. So for this huge solving diagnostics campaign, we are involved in many people from CNR and from Opificio delle Pietre and from the superintendents of cultural heritage in Florence. The main problem is the recognition of the constructive building sequence and understand some problem of swelling and bowing present on the fresco. In order to understand the nature of this problem, we must understand the location inside of the monastery of the Brancacci chapel. We have around the chapel, this is highlighted of the portion of chapel in the building. There are many rooms and environment with a different destination. For simplicity, we concentrated our attention on this scene of the healing of the cripple on the rising of Tabitha, painted by Masolino. The first investigation it is the visual inspection aided by spotlight for creasing light investigation, and so we can detect some defects on the surface. But we need to understand the size of this defect. So for this topic, we need to realize a 3D model. This 3D model has been realized by photogrammetry photographic survey, and we can start from this model the photo planes of single scene, and also the digital elevation model for understand the size of this swelling and bowing. Because by the 3D model, we can determine the metrical size of object and the position on the scene, on the photo planes. So a contour lines of the single scene, we can help us to understand where is the deformation and what is the size of this deformation. Overlapping these contour lines on the scene, we can try to better underline and localize the other measurement, other investigation. The principal question is understand the nature of this swelling and bowing, and what is the consequence for the conservation of these of the wall paintings. And for understand that, we applied a multi-scan and multi-resolution analysis from macro to local analysis. The start point for this investigation is the infrared thermography. By the infrared thermography, we can highlight the discontinuity of the detachment of the wall paintings, and also the old refacement, the wall texture remakes in the past. and these confirm some relief obtained 30 years ago by previous diagnostic campaign. The actual investigation improve the quality of this investigation by IR thermography, and we can extrapolate some information that we don't able to understand before. This is the remake that overlap on our IR thermography. And in order to understand the consistency of the masonry, we take other information for in-depth investigation by ground penetrating radar. In this case, we used two kind of ground penetrating radar operating at two different frequency, 900 megahertz and 2 gigahertz, because by the first one we can go more in depth about until 60 centimeter in depth. We report on these 4 slides the results at a different depth, and we can observe the presence of fracture inside of the masonry at a different level, the remake of the window before discovered by IR thermography, while by the 2 gigahertz ground penetrating radar system, we can perform an investigation on the surface up to 15 centimeters. But the resolution is not enough, so we need to improve the resolution in this first 15 centimeter up to 1 centimeter. So we try to develop this new system, the microwave reflectometer, that operating in this way. This is a sketch of the stratified medium. This is the interface from air and the wall. The first layer is the first part of plaster in Tonachino, where we applied the painted. This one, the second slice, is the air gap, and this is the masonry, stone, brick, and so on. Our intention is to understand where is the position of this gap and what is this size. In order to make that, we must recover the information by the physics. We have the limit due to physics, and the maximum range for detecting the discontinuity is due to by this relation, so depend from the band of operating, the band of frequency of the systems, and from the material characteristics from electromagnetic point of view. While the resolution depend from the sides, in particular from the sides of the operating frequency band. In this case, we operate with these in this range. So the bandwidth is 12 gigahertz, and the maximum resolution is less 1 centimeter. This is the characteristic, the electromagnetic characteristics for a typical plaster with dry condition and in wet condition. Just an example for this particular on the fresco of this is a little giornata, and we have a detachment on this part, and we can detect we scan the surface by the microwave reflectometry in this way, and in this way in order to detect the difference of constitution. At the zero line, we have the interface between air and the painted layer. And at 3 centimeter in depth, we have the discontinuity between the plaster and the masonry, maybe a brick. In this case, that correspond on the little figure, we have a great discontinuity close to the surface, and this discontinuity is due to the presence of the detachment behind this little figure. So this detachment is localized in depth at less of 1 centimeter, and the size is less than 1 centimeter. Actually, the survey of detachment problem on frescoes is made by knocking method, and so is not an objective practice. An objective results depends from the sensitivity of the restorer and the experience of the restorers. So in order to objectify this information, we applied a new, quite new method, but new for the applying in for this kind of topic, the digital holographic speckle pattern interferometry. By laser ray, we can found the movement of the plaster when it's excited by a source of color. This is the IR lamp for induce an heating on the surface. And by this camera, we can detect the variation of the laser ray in position of the reflected laser. Always refer to this little figure. We hit the surface for 90 seconds, and we collect in the time the interferogram after turn off the heating. This is the overlapping of the interferogram with the visible image, and we can observe that we have a discontinuity around the edge of the little figure. After about 1 minute, this difference increase is more evident. And after a long time, about 4 minutes, the area surrounding the little figure is come back to the environmental condition, but where we have the detachment, the interferometry continues to have an evidence. So these many information obtained by scientists with different kind of system has been introduced in the new platform, Brancacci POV, realized by our Digital Heritage Innovation Lab, that change the perspective to disseminate and valorize the work of scientists related to the importance and the evidence of the historical information. I'd like to suggest you to visit this experience by this link to have other information and to discover what has been realized in this test site related to this 3D environment. We can realize hybrid experience to transfer the historical identity, cultural identity for this site or for other site. So in conclusion, by this interdisciplinary approach based on the multi-scale and multi-resolution activity system, we can understand the stability of the wall paintings, and we can able to monitoring to define a monitoring strategy for the future, and we can we can try to diffuse to develop a new experience like Brancacci POV to improve our work and to improve our the importance of our cultural heritage and the conservation of our heritage. Thank you for your attention.